Today, I plan to begin the fourth topic that you have, Keynesian cross model. This is a straightforward Keynesian model, not much complication, the simplest Keynesian model, and I think you would enjoy this. It's not going to be difficult at all. So let's begin with the simplest Keynesian model today. As you can imagine, in comparison to classical model, Keynesian model would have a role for the government to play in the economy, in the sense that policies will matter. So the model will be very different, quite different from what you have seen earlier. So topic 4, the Keynesian cross model, is something which that I begin today. Topic 4. How am I writing? This is how I'm writing, topic 4. Topic 3, that's how I've written. Okay. Keynesian cross model. Okay. This Keynesian cross model, the first thing that I should mention is that it has, since it is the simplest model, it ignores a number of things which we will consider later. So the first thing to note is that it is a short run model. Second, it considers only goods market. Hence, ignores money market and labor market. And it ignores the labor market quite cleverly. What it does is that it makes some assumptions in the short run which makes the supply curve in some sense passive, not active. In the classical model, what you have seen, because the supply is vertical and so rigid that it becomes the most important function and demand doesn't have a role to play, because demand shifts will only change prices, will not change output. Supply curve, employment, output, etc. are all determined by the labor market. In the Keynesian cross model, you're saying just the opposite. You are making assumptions which will render the supply curve ineffective, relatively speaking, and the demand curve becomes most effective. What do you think the aggregate demand supply diagram would look like, where demand is most effective and supply is kind of ineffective in determining output? How would the demand supply diagram look like? Common sense answer? Demand line is vertical, very good, and supply line is upward sloping. Not a bad suggestion. Now we have slightly different thing. That also would give you the result that I talked to you. Slightly different. What it assumes is that in the short run there is unutilized capacity in fact, a vast amount of unutilized capacity. So if companies have built-in capacity to produce more, which they are not using because the demand doesn't exist, so companies are not producing. IIT Kanpur has constructed various classrooms and faculty office spaces. But if you don't have enough students, if you don't have enough faculty, these spaces would remain unutilized. So tomorrow, if you do find students and if you do find faculty who can come to IIT Kanpur, it doesn't increase the cost in a marginal sense to IIT Kanpur because these buildings already exist. Some variable costs will increase, like the fan and the light will be switched on, etc. Largely, they are all built in, created capacity, which are remaining unutilized. So what happens in this short run, this unutilized capacity and short run, they are all connected. This is essentially, I'm saying, a feature that exists in the short run. In the long run, it may not be the case at all. That unutilized capacity in the long run or medium run may turn out to be insufficient. You need more classrooms, more faculty offices. But what that time period would be, we don't know. But at least in the short run, say in the coming year or 6 months, there are enough spaces and for teaching, classroom spaces, and enough faculty offices at IIT Kanpur. All right. Therefore, unutilized capacity and short run would run like this. Okay? They are connected. Having said this, therefore, the model that I am going to construct is unutilized capacity. It follows from kind of microeconomics under a few more assumptions maybe, that what effectively we are doing is that we are creating a world or an economy where output can be supplied to the economy as soon as there is demand. The capacity is already ready. You tell me how much you need. I will produce that for you. All right. So the aggregate supply curve is kind of horizontal. That's what we will make. All right. So it becomes very passive. It doesn't determine the output level. What determines the output level is that the demand position, aggregate demand position. If for any reason aggregate demand shifts out, no problem, supply capacity is there, companies would just meet your demand, supply the extra output. Suppose the aggregate demand shifts out to another place, all that will happen is that output level from Y0, it can easily change to Y1. Now, in the process, companies are not required to change the prices, or aggregate prices in the economy do not change. It's such a short run period. You have unutilized capacity in the economy, aggregate supply curve is horizontal, that is, it can meet any demand. You tell me how much demand you have. So it becomes essentially a demand determined model, just the opposite of the classical model where it was entirely a supply determined model. The supply curve told you how much output the economy would produce. Demand had a passive role. It only determined prices. In this case, the supply curve is determining the prices and keeping it constant in the short run, and the demand curve would tell you how much output will be produced. If demand shrinks, goes backwards, output in the economy would go backwards or fall. If demand increases, output would increase. So it essentially becomes a demand determined model, just the opposite of the classical model. Demand determined model. That kind of a short run I'm talking about. there is no problem in supplying what you need. Question is whether you need that or not. There is no supply constraint. All right. Now, as I've said, that we would ignore the money market, we would ignore the labor market. Labor market is ignored because the labor market gives you the supply curve. If the supply curve is horizontal, what happens in the labor market is of no importance to us. So it is rendered unimportant. With a supply like horizontal curve, well, who cares what happens in the labor supply? That means there must be excess labor waiting to be employed. As soon as companies are asked to produce more, they would just hire them and produce them. There is no wage increase. There is no price increase in the economy in the short run. All you require is to produce and meet the demand. All right. So we would consider only the goods market. So we got to model, therefore, only the goods market. Now, in a Keynesian model, the goods market, we will model them under two simple assumptions. I would first consider case A. First consider case A, where there is no government. So I would consider a model without government. Now look, right from the beginning I'm talking about government. We are in a Keynesian model. Government has a role to play, they always say, unlike the classical model. So I'm already talking about government. So it occupies an important place in the model. So without government, I would model. Now the goods market, we got to model the goods market. Now how do we model the goods market? We model the goods market in terms of demand and supply. All right? Okay. So suppose we would again impose equilibrium conditions or market clearing condition. Equilibrium condition will be supply equal to demand. Achha. Now supply and demand will be equal. What is demand? What is demand? Now, what is demand? Go back to the expenditure approach under national income accounting methods. What did I say there? The total value of goods and services produced in the economy is indirectly measured in terms of the expenditures incurred on consumer goods, investment goods, government goods, exports minus imports. Take a simple case. By the way, I may also like to add one more assumption which people forget. These are all closed economy models. There is no export and import. So it's a closed economy model. That I should also add. There is no export or import. It's a closed economy. When you have export and import, it's called open economy. We are not going to have an open economy. It's entirely closed economy. All right? So, in the closed economy, what is demand? With no government. Well, demand, say call that D, is equal to consumption demand, which is the expenditures you incur on consumer goods, measures the demand for consumer goods. So this is consumption demand plus in private investment demand. Plus private investment demand. Let's call that C plus I. These two notations we would use. You have seen these notations earlier. C is for consumption demand, which is essentially the total expenditures incurred on consumer goods, plus investment demand is the total expenditures incurred on investment goods that can measure investment demand. Now, therefore, what you are essentially saying This equilibrium condition will be therefore total output produced in the economy, supply of output should be equal to C plus I. That's the equilibrium condition you have. Y is equal to C plus I. That's the goods market clearing condition. Clearing means there is no excess supply of goods, no excess demand for goods. You are talking about an equilibrium condition, and the equilibrium condition essentially says supply is equal to demand. The equilibrium condition says supply is equal to demand. The supply of output we always measure in terms of Y, that notation, which also means real income. I told you why. Total supply value of output measures the total income generated in the economy. I also told you why so. So it is equal to C plus I, demand for consumer goods or consumption demand plus private investment demand. All right. Now, we are going to make a further assumption, a couple of more assumptions before we get going, that are very Keynesian, or one is Keynesian, one is not so Keynesian, but for the sake of this very simple model, we are going to make it, but assumption, rigid assumption, but we are going to drop it later. We are going to drop it later. It's a very oversimplifying assumption. We need it now, we don't need it later. We will drop it. So what are the two assumptions that we are going to make? The two assumptions we are going to make are following. Let I be equal to some I naught, which means autonomous investment. It doesn't depend on any economic variable. Autonomous investment. Autonomous means independent. It is not affected by a variable from the macro model that we are building, we are constructing. Autonomous means X depends upon Y, Y depends upon X. All right? X depends upon Y, Y depends upon X. These are endogenous variables. So one affects the other. But suppose there is a variable Z, which is not a function of X, Y, or any other variable, is an autonomous variable, which we often call an exogenous variable, which is like outside the system. Now, investment is not an autonomous variable, investment is not an exogenous variable in the real life. It depends upon what happens in the economy. But we will make that realistic assumption later. For the time being, we will have investment is equal to I naught, which is an autonomous investment. All right. This is the first one, just for the sake of this model. Second, we would follow Keynes. Following Keynes, we will assume, or we shall assume, a linear consumption function. We will assume a linear consumption function. Consumption is equal to some autonomous component plus a small c, which is the slope of the function, into y. C lies between 0 and 1. C naught is called autonomous consumption. Small cy is affected by y, consumption is affected by y, it is multiplied with y. So a small cy is known as induced consumption, not autonomous but called induced consumption. And small c is known as marginal propensity to consume. It's called marginal propensity to consume, small c. So we have assumed a linear consumption function, like y is equal to mx plus c. M, the gradient of the line which measures the slope, in this case is small c, and y is equal to mx plus c, the c constant term of a linear function here is autonomous consumption, c naught, and the gradient is telling you that consumption in this world, the one we are going to assume, changes with the income level. It makes sense. Keynes had an elaborate discussion in one of the chapters in his book. These are the changes Lord Keynes, John Maynard Keynes is making after having learned classical macroeconomic model from his teachers. Imagine now you would slowly realize the changes is brought about in one book in the entire macro model. By the time I conclude this course, you would realize how much he contributed in one book only. People write hundreds of books. People don't talk about it. In one book. The first important thing that I'm bringing in as a Keynesian element in a macro model is this consumption function. It is saying that human beings psychologically behave in the following way. Even if they don't have income, they cannot live without consuming. So they will have an autonomous consumption component which will not depend upon income or anything else. And how, you can ask me, sir, how will he consume if he doesn't have income? Because you require income to purchase the goods. Well, it's very simple. An unemployed person either uses his past income, or one who has used up the past income would borrow from brothers, sisters, friends and consume. Otherwise, he would starve to death, which can also happen. So this consumption function is not meant for people who would starve to death. This consumption function is meant for people who would consume something. So the consumption function is basically saying at the macro level, even if a country doesn't have any income, imagine this is not private only. This is the entire country's consumption function. So what it is saying is that even if the country doesn't have any income, it still consumes something. And it consumes on the basis of borrowing or aid, which often happens. Countries do receive aid, help from other countries, in good terms, in real terms, in money terms also. IMF gives them aid, World Bank gives them aid, another country gives them aid in terms of wheat, rice, other grains, etc. So the aid can be in physical terms, the aid can be in money terms. So a country will always have an autonomous consumption part. The second part, which is more interesting, which he said, human being psychologically has a propensity to consume out of any income it receives, which is true. If it receives income, it doesn't put the entire income in the bank. It would spend something. But the marginal propensity to consume, if you do a calculus, if you differentiate this, dc dy is small c. You can see that from the function. So dc dy is marginal propensity to consume, small c. The small c is less than 1, positive but less than 1. So another thing Keynes said, which is very normal, very logical, is that when you get an extra 100 rupees, you don't spend the extra 100 rupees, at least as a family man. As a child, you can do that. You immediately spend it. As a family man, what you do, they're talking about adults in some sense, you would spend a part of it, and a part of it, what will you do? If small c is less than 1, you're not consuming the entire money if small c is less than 1. If small c was 1, then the induced consumption would have been any y is equal to c. So if small c less than 1 means any extra 100 rupees, 200 rupees, 500 rupees, 1000 rupees you may get as income today. Suppose IIT gives me an extra income. Of course, I will go out with my family and spend some of it. But a part, psychologically speaking, what human beings do is they save it. So what he is doing, essentially writing this consumption function, he is also telling you that there is a savings function in the background, which is becoming effective and important. Now what did you have as a savings function in the classical model? It depends upon real interest rate, the bank interest rate. And this savings function is going to be very different. So you can see the change is happening now in comparison to the classical model. All right. So this is the famous consumption function that he talked about. All right. Okay. Now you may ask me, sir, if that is true, in the background there is a savings function. So I use the income identity to know the savings function. So recall the income identity. Y is equal to C plus S. Therefore, S is equal to Y minus C, which is Y minus C naught minus small cy, which is minus C naught plus 1 minus small cy, or S is equal to S naught plus small sy, where S naught is equal to minus C naught and small s is equal to 1 minus small c, implying that C plus S is equal to 1. It's very simple, this algebra. It makes sense. So what you have in the savings function, you have also a linear savings function, because you had a linear consumption function. So you have a linear savings function, and in the linear savings function there is a constant part which is a negative term. It is minus C naught. It's very important. When it is minus C naught, what is it saying? That when there is no income in the country doesn't save, the country dissaves. The negative of saving, dissaves, which means the country lives on borrowed money, borrowed goods, which it doesn't produce. It borrows, like a human being who doesn't earn, he lives on borrowed money. So the savings function is saying the autonomous component of the savings function is the flip side of the autonomous consumption component. Since it's the flip side, it has a minus sign, all right, the inverse of it, the opposite of it. And the minus sign is telling you that at zero income, the country dissaves. And then also you have a induced part of the savings function, which is function of y. And that induced part, you also have the marginal propensity to save, just like the marginal propensity to consume. This small s is nothing but, you can call that the marginal propensity to save. Like small c is marginal propensity to consume, small s is marginal propensity to save. This part is marginal propensity to save, and the marginal propensity to consume plus marginal propensity to save will be equal to 1 from this identity. If S is equal to 1 minus C, S plus C is equal to 1. So what the story he is trying to tell you, which is everybody knows, that the income we bring home, we spend a part of it and we save a part of it for future. That is the human psychology. And he calls that the psychological law. When he starts describing and talking about consumption function, imagine 1930s, nobody heard of consumption function. They only have seen the classical model around that time. His teachers also taught him, and he's writing a revolutionary book. So he uses the word like the psychological law. See, he borrows terms from psychology. So the human psychology says if you earn something, you don't spend everything. Well, a gambler, an addict would do that, won't think about the future. But the human psychology is that you also think about the future. When you don't have enough income, you need something to live. So you have a savings aspect. So in his savings function, which also is a consumption function as attached to it, they are flip side of each other, like the coin has a head and a tail, is part of the same thing. If you have consumption, you have savings, is something which was not there in the classical model. In the classical model, consumption didn't have a function. Consumption was a residue. If the economy has saved this much, given the interest rate, which matches the investment, now from the income identity you can find out how much is the consumption demand. So consumption was a very passive variable in the classical model. It's a residual variable. Residual is what? I have a cake, I distribute that cake to some people and then tell a person who is sitting beside me and help to make the cake, which may be the truth in many cases. I sell whatever remains, you can have it. Residual. So after having saved, whatever remains you can consume. That kind of a thing is there in the classical model. There is no consumption function. Keynes for the first time brought in consumption function. And therefore, you see there are differences in the savings function. If you write a savings function or a consumption function, savings function is not a function of interest rate anymore. You can say, sir, that can be a drawback too. I do save depending upon the return I get from a saving also. So in some sense, consumption does become residual. But Keynes is taking it in a direction where it may be opposite to the classical. Imagine a complete rebel in some sense. What his teachers taught him is rejecting them and taking a different path, the subject. Of course, it can have drawbacks, but it does open up new things which people didn't see until then, didn't think about it. And part of that makes sense. Human beings do save for future, depending upon the income. So when they receive income, a part they consume, depending upon MPC value. Remember that MPC value, small c, or margin permits to consume, or margin permits to save, is not the same number for every individual. Who loves to spend would have a high C value, and a miser, whom we call miser, who doesn't want to spend, would have a small c value and a high S value. And there are various studies done. There are very interesting studies done. When you go to the poor income group, their demand is so high, and most of the demand have not been met. Most of the demand have not been met. Whenever they get an extra income, they tend to spend nearly the whole of it. They don't have any saving. So what's happening is, in a poor income group families in a country, you will see marginal permits to consume is very high, because they haven't seen a TV and a mobile phone and good food, good clothes, good education. If they get some money, they immediately spend. When you come to a rich family who has seen most of it, their income levels are so high, all their basic needs are met, you will see a marginal permits to consume a much lower number. So marginal permits to consume became an issue after Keynes's book. And I'm just developing the model. I haven't developed the model yet. The entire thing, it will slowly develop. But are you following me? Are you enjoying it, or may not be enjoying it all the time, but at least you are following it, I hope. So this is how Keynes started developing the new macro models. And we have a very simple one to deal with first. Then we get into more complex ones. Now, imagine just introduction of one consumption function, what more it did. Now you watch. I'm going to show that to you. Just watch the algebra. I'm going to conclude this part. Have you followed this? So now, the equilibrium condition, please write the equilibrium condition in terms of using the consumption function. What will it become? The equilibrium condition using the consumption function. What will it become? Therefore, y is equal to c plus I naught, or y minus c is equal to I naught, or s is equal to I naught. Now this part, s is equal to I naught, is a very familiar thing. In the goods market, in the classical model, the same equilibrium condition was used. Same equilibrium condition, savings is equal to investment, except the savings and the investments were function of rate of interest. Here we have in this simple model investment as autonomous or constant and savings is a function of income. So the economy reaches equilibrium when given an investment demand, some I naught value, when the economy produces enough income which renders a matching amount of savings with investment, then the economy reaches equilibrium. That's what it is saying, nothing else. Can I use one diagram before we take a break? A very simple diagram. Why it is called cross model? You can see a line crosses something. That's why this is called a cross model. So this equilibrium condition is familiar, but we arrived at with using different functions, different kind of things, which in the classical model we didn't have. All right. Let's draw a diagram where this axis has y and here I measure demand. What are the demands I have? Recall D is equal to C plus I. So the C line is like this, which is autonomous consumption is C naught, and this is C is equal to C naught plus small cy. Add autonomous consumption some amount, so you have C naught plus I naught, and you have the aggregate demand line. You have the aggregate demand line as C plus I line, like this. D is aggregate demand. For equilibrium, you require D to be equal to Y. For equilibrium, you require the D variable value to equate with Y. So what you need diagrammatically, you need a 45-degree line, because on the 45-degree line through the origin, on the 45-degree line through the origin, D will be equal to Y at every point. So all we need now is a 45-degree line, which I am going to, without a ruler, I'm trying to draw that something like this, which is the D equal to Y line, equilibrium line, where the angle is 45-degree. So now you tell me, given the demand curve drawn in a very different way, upward sloping demand curve like C plus I naught is the total demand, equals to output equilibrium. Where is equilibrium reached? At this point where the height D is equal to the x-axis intercept, which is Y. So this is where equilibrium has been reached. So this is the equilibrium value of Y. You can call that YE if you wish. This is the equilibrium value of Y. All right? Clear? The model that I have drawn. But for Y is equal to C plus I, we also have a version of the equilibrium condition, S is equal to I naught. I don't see, sir, you can ask me, sir, I don't see that on the diagram there. How do you draw that? Well, to draw that, draw another line here and draw a line like this, again Y, but draw the savings function here. Now this is the zero value. So at Y is equal to 0, this is the amount of this saving. C naught is equal to S naught, I said. So this amount of this saving is taking me to S naught value here, which is equal to minus C naught value. And when C naught crosses Y, all right, C naught crosses Y, you can see that when C naught is equal to Y, C naught is equal to Y, then what you have here? Not C naught is equal to Y, when C is equal to Y, the entire consumption is equal to y, S is equal to 0. So at this point, when the consumption line intersects the 45-degree line, that is consumption, this is the height of consumption because this is the consumption function. The first line is the consumption function. So at that point of y, what you have here is the savings is 0. So the savings line is like this. Where that angle here is some alpha, where tan alpha is equal to small s. And the angle here, this angle, say some beta, where tan beta is equal to small c, the marginal propensity to consume. The slope of the savings line is marginal propensity to save. And this intersection 0 value, so this is a negative value here on the y-axis measures savings, then the negative value, and here you have the positive value. At some income, you can call that YB income. I will explain that why it is called YB level of income. At YB level of income, what you find is consumption equals income, therefore savings are 0. After that, if you have any income, you are going to have savings is equal to consumption. Now the question is, at the equilibrium point, this is the equilibrium point, call that E, the equilibrium point. Do you have savings is equal to autonomous investment? So essentially what I'm trying to say is that this height, the difference between consumption and aggregate demand is investment, should be equal to the savings on the savings line. So this part and this part, they should be equal. This is essentially S is equal to I naught. This is I naught. And this part is some S at the equilibrium point. So at the equilibrium level, at E, you will have I naught is equal to S. At any other level of income, you take this income, you will see savings more than investment. Any lower income, you will see savings less than investment. Investment is the gap between the two parallel lines here. That is either more or less than the height here. At the equilibrium point E, you will have investment equal to savings. The algebra that you have seen on the board earlier. And why is it called Keynesian cross model? You can see in a very funny way we draw the demand lines, upward sloping, and it crosses the 45-degree line to give you the equilibrium. And this part, this version of Keynes's model was not there in Keynes's book. It developed later with some assumptions of Keynes's model, and it has come to be known as the Keynesian cross model. It has come to be known as a Keynesian cross model. People later gave it a name. It incorporates some assumptions of Keynes's, not all. And they came up with this simple version of Keynes's model. In a very funny way, demand lines are drawn, upward sloping. There is no price in the model. Look at it, no price. Because you remember in the short run I said price is fixed, so I can ignore price. All I have is the real demand and real output. And equilibrium is real demand is equal to real output. Price can be ignored because the price line is a supply line which is fixed. So there is no possibility of price change. If you have any possibility of price change, then this diagram will be ineffective because there is no room here for a p variable. So we will require a different diagram where p is a variable. But this simple Keynesian model, which incorporates a few assumptions of Keynes, has come to be known as the Keynesian cross model. Interestingly enough, with different assumptions, we do arrive at the same goods market clearing condition, which is savings is equal to investment. Although savings is a very different function now. That's very interesting. We arrive at the same goods market clearing condition which you had in the classical model. If you open your notes, you will see that. The first equation, SR is equal to IR. We don't have R here, but we definitely have a similar kind of a condition, S is equal to I. I is autonomous, S is a function of income. Is this diagram clear? Okay. Now, this is nearly coming to the end of the first part of the Keynesian cross model. I have 2-3 more stages to go. This model is algebraically not complex, but conceptually new to you because you haven't seen any macroeconomics. As a matter of fact, you haven't seen any economics before this probably. So you are seeing macroeconomics the first time, and my job is to explain things to you. Now, the income level at which savings is 0, that is the savings line intersects the x-axis, which I've indicated on this diagram with YB level of income, where consumption is exactly equal to income in the country and savings are 0, has a name in these textbooks or discussions. It's called break-even income. Break-even means you exactly balance something. So your breaking even means basically you earn enough for your consumption, you still don't save. At an individual level it can happen also. A family earns enough to consume, like a poor family, and has 0 savings. No dish saving, they are not borrowing from anybody, there is no more dish saving, but they are earning enough to have all their basic needs met, and they are not saving either anything for future. So YB is called break-even income. This is a term you may come across in books when you read them. YB is called break-even income. It's called break-even income. This is one thing you have to note. The second point to note, with this friend of mine who wanted to discuss something pointed out, I was about to do that, but I stopped myself. You note this line, the diagram. If today the line which is called the aggregate line, which is C plus I, aggregate line, or the C line, the aggregate line or the C line are the same in the sense only autonomous investment is there. So the line's slope, not the position, the slope depends upon the C function, because the slope of the line is small c. If you differentiate that and find out the slope, you will get small c. You notice one thing, if the line becomes steep, then the line, aggregate line C plus I, intersects the 45-degree line to the right. So there is an increase in income in the economy, or output in the economy. If the line becomes flatter, then it will intersect the 45-degree line to the left of where it is now. So the income level would drop. So depending upon the slope of the aggregate line, it tells you whether income would be higher or income would be lower. You can see that clearly. It's very clear. This is a very important intuition which usually books don't write. They go straight into an algebraic derivation. If this line is steeper, it would intersect the 45-degree line to the right, and there will be higher income, higher savings. If this line tomorrow becomes flatter, then it would intersect to the left, so the amount of income, etc., would be smaller. It's very clear that the slope of the line is a very important variable, which is small c. If small c increases in the economy, this line will become steeper, and the equilibrium output income, everything will increase. If small c, marginal propensity to consume, drops in the economy, then the line will become flatter and the income output, everything will drop in the economy. Is that clear to you? Geometrically speaking, relating it to small c. So marginal propensity to consume, which comes from the consumption function, seems to be a very important parameter for the macroeconomy. Because depending upon what the marginal propensity to consume is, the income and output in the economy would be consequently determined. All right? You see that? This is the second thing from that consumption function that is coming out, is that the actual income or output in the economy does depend upon marginal propensity to consume. So in a country where marginal propensity to consume is high, people spend a lot, will have a higher income or output. My children demand more, so I will have a tendency to supply more to them. My children demand less, I will have a tendency to supply less to them. If the country demands more goods, they tend to spend more, the economy also produces more. This is one of the reasons why multinational companies are more interested in coming to India, is that the marginal propensity to consume in this country is very high. It's a country also with very big size population. So they can sell more, they can produce more, make more profit. Very simple. And this kind of insight is also there from Keynes's macro model. Marginal propensity to consume. Now let me formalize this argument by taking it one more step further. From this algebraic equation, I would use a different color chalk. You see there is a thing that is coming out which is very interesting relationship. From this, I can also get y is equal to C naught plus small cy plus I naught. Also, if I take cy to the left hand side, you have 1 minus small c into y is equal to C naught plus I naught. Or you can solve for y as C naught plus I naught over 1 minus small c. Clear? This is in fact class 7 algebra. So class 7 algebra shouldn't bother you. Good, the mathematical part is not complicated, but the intuition economics is very important. What it is saying, what I just told you, if this c value increases towards 1, what happens to the denominator here? Falls. The ratio goes up. The equilibrium value goes up. Y value. Just now what I told you. This leads to another very interesting now relationship. Let's call this A naught over 1 minus C. A naught is C naught plus I naught, where A naught is equal to the autonomous components C naught plus I naught. All right? Okay. Now, here we go. Suppose there is a shift in the autonomous variables, C naught, I naught, or whatever, both of them or one of them. Companies decided to invest more, buy more machines, expand their factories or whatever. They want to do that. Suppose I'm coming out of the short run period. I'm going into another short run period now. They decided to spend more. All right? So there is a delta A naught amount of increase. What will be delta Y? Delta Y will be equal to 1 over 1 minus C into delta A naught, the autonomous parts. Since C lies between 0 and 1, delta y will be some k naught times delta a naught, where k naught will be greater than 1. Simple algebra. C is a fraction. 1 over a fraction is a number greater than 1. Very simple. C is a proper fraction, say 1.7. So 1 minus 0.7 is 0.3. 1 over 0.3 is 3 point something. Ho gaya, come. This is the second contribution that follows from the consumption function. One thing he has changed. Look, the results you are getting. If there is any autonomous change in the economy in terms of induced consumption, in terms of autonomous consumption or private investment, which is often discussed, and we will discuss other variables later, the impact on output or income, real income, is multifold, manifold. So if autonomous investment increases by 100 crores, 0.7 is the marginal propensity to consume. The K value is 3 point, how much? 0.3, so 3 over 10, 10 over 3, 3.3. So the delta y increase in output will be how much? 330 crores, 333 crores. For 100 crores increase in investment, the output increase and the real income increase in the economy will be 333 crores if I assume the marginal propensity to consume to be 0.7. If marginal propensity to consume goes up now to 0.8, then 1 minus 0.8 is 0.2, then the multiplier value k, which I call multiplier, k is therefore 5. So 100 crores of increase in investment, extra investment, delta I or delta A, excuse me, will lead to delta y equal to 500 crores. So the marginal propensity to consume, therefore, is a very important parameter, which gives you another insight that if there is any shock to the system in terms of increased investment demand, or the reverse can work also, if the investment demand falls, the negative impact on output is huge. Reverse direction it can also work. Acha. So what you see here is the famous, this is known as autonomous expenditure multiplier. And that is also because of Keynes's consumption function. It wasn't there in the classical model. Multiplier means essentially something which multiplies. So autonomous expenditure multiplier is this small k. That's very important, which is greater than 1 value. You get the second very important result here. First, looks like I'm trying to be clever and stating the same goods market clearing condition which we had in the classical model, which is savings is equal to investment. No big deal. But when you look into it, what he has done, you realize there are many more things that are following. One of them is the role of marginal propensity to consume. From a very simple linear function, I've demonstrated that. Consumption function may not be linear, it may be non-linear, but I don't want to complicate my life or your life right now. Even with a linear function, you get amazing results coming out. There is something called a multiplier at work in the economy, where if expenditures increase, it will have a multiplied effect, maybe over a multiple time period, multiplied effect on output. Question is, you didn't ask me, I would try to explain that next. Why is there a multiplied effect? How? What creates the multiplied effect? If firms invest 100 crores more, 10 months later or 2 years later, suppose I have 300 or 400 crores worth of extra income or output. Why is it so? What creates that? That's my next job, is to give you the insight, the intuition behind the multiplier. And you can imagine my intuition would be definitely dependent upon the marginal propensity to consume. What role marginal propensity to consume has will become even clearer when I give you the intuition as to why the multiplier exists, which we will call later expenditure multiplier simply. Now we have only autonomous variables and we are calling it autonomous expenditure. Why is the multiplier working? Okay, let my next job is to explain why this multiplier exists. Then I will go into other issues. So geometrically, you can draw an increase delta I with aggregate demand shifting up to this point, but the intersect on the x-axis will give you an increase in y much larger than the vertical increase on the y-axis. Clear? Vertical increase in the y-axis measured with the actual increase in income, when this line shifts, you will see they are disproportionate. This is much larger here for a small shift in this line, which I explained there in terms of that multiplier. All right, geometrically speaking, what will happen? Okay. Now let me try to explain why the multiplier works. There is an algebraic proof which explains the intuition quite well, which I prefer to use. Why the multiplier works. The algebraic proof or intuition behind the multiplier is as follows. The companies have demanded an extra amount of autonomous investment, right? 100 crores. Those they start placing demand for machines, tools, resources, for extra 100 crores worth of goods, investment goods. Companies have placed them with companies who produce them. Firm A, firm B, firm C, firm D, whoever. Once they start meeting that demand in this economy where there is unutilized capacity, they start producing them. Extra costs don't go up much, additional cost. Of course, you have to incur costs to produce extra goods. Extra costs are not rising. No additional costs in this simple world. Prices don't increase. What it does, when everybody, company A, company B, company C starts producing extra machines, extra computers, extra fans, extra nuts and bolts, extra other tools, they are hiring resources, people, producing them and generating income. In this simple world, let's assume that after the first period, this amount of demand has been placed on various companies, by companies, by firms who are investing extra, creates an extra amount of income, because this amount of good will be supplied. It creates an additional amount of income called delta A, which is an additional amount of income it creates. And when this income, people who are households go home, they spend C amount of it. Marginal propensity to consume is C in the economy. So they would be therefore placing C times the extra income as demand, new demand in the economy for all sorts of consumer goods. Rev mein khana, kapra, film, TV, new cars, whatever they are buying. So suddenly after the initial demand for machines, etc., because of autonomous investment increase, which creates an additional amount of income generated in the economy equal to delta A, consumers, when they come home with that income after working in the companies, they place an extra C times of that in terms of extra goods that they would like to buy, because they have extra income now. Take a consumer goods. This consumer goods create C times delta A naught amount of income, because the consumer goods factory is now producing more consumer goods, more butter, more jam, more shirts, more pants, more automobiles, more ACs, have more income, buy AC, it's very hot, an extra fan, an extra cooler. Okay? So that generates an C times delta A naught amount of income again, where consumers go home with that extra income, householders, having produced that, they go home with that income, and their per children and per wife and etc. they say, now let's spend out of it. So in the next period, they will spend C of C times delta A naught of income. Again, when they place C times delta, an extra amount of consumer goods demand is placed, which is C of C A naught, which will be produced and generate income. And when they go home, they will spend again C of C square delta A naught. So this process seems to be going on and on. Every period an income is generated. C times is spent from that extra income, extra demand for goods, which requires production and generates again that amount of income, which income dissipates when they go home, they start spending out of it. So the total process, if you add them up, goes to infinity. And that is the total income that is generated, delta Y, over a successive period of time. Now this is the geometric series, infinite series. To sum the geometric infinite series, what you have? Common factor is C, so it will be 1 over 1 minus C into delta A naught. Delta Y is equal to 1 over 1 minus C into delta A naught, which is precisely the multiplier we have there. So why the multiplier works? Because of the existence of C, or the discovery of C by Keynes. And now you have a second very important result, that there is a working of a multiplier in an economy. When extra demand is created, it's just not one time an extra amount of goods are produced. It has a multiple ripple effect, like when the wave comes towards the shore, you will see the large wave followed by a little bit smaller, and then a smaller one, smaller, and then finally dies down. A series of waves lashing on the shore. So when an expenditure extra boost happens, in one period it happens, it has a subsequent multi-period effect on the economy, and the total amount, using mathematics, I can count that by addition method, geometric series addition method, to be a multiplier at work. And essentially that small c is very important. Is the intuition clear why a multiplier works in the economy? This insight wasn't there, working of a multiplier, even if they had acknowledged it, at least not in their academic papers among classical macroeconomists. They never talked about multiplier, even if they had acknowledged. Sometimes for political reasons you don't. You know that works, but it disturbs your premise where you stand politically, so you don't want to mention that. But you very well know that works. Keynes brought it out. All right? So this is the first, I'm concluding the first phase, first stage of the Keynesian cross model with this multiplier. And the intuition is clear. All right? Clear? Okay. Second stage, I want to talk a little bit about some stability issues, which we do a lot in microeconomics, not so much in macroeconomics, but I want to talk about a little bit of stability issues. This equilibrium that the economy reaches, is it stable? It's a theoretical question. In microeconomics, stability issues are discussed in terms of something called second order conditions. Like if you have a maximum, how do you know it has reached maximum? The curve must be declining after reaching a maximum. So the second derivative of a function should be negative. if you reach the maximum. Otherwise, it can be minimum too, because the first derivative is saying is a tangential condition, which is 0. When you reach a max or a min, the first derivative, which is the tangent, is always flat, is 0. But you don't know whether you've reached a max or a min. To ensure that, you bring in the second order conditions at least, if not the third and the fourth order conditions. The second order condition which we use in microeconomics is, for a max, in mathematics is coming from, the second derivative should be negative. For a min, the line must be going up, it has reached the min, so the second derivative should be positive. In macroeconomics, that we reach equilibrium points, how stable are they? That's the issue we ask. If you reach, do you reach that or go and come out of it? Are these multipliers stable? We ask the issue similar to microeconomics second order conditions is the stability issue. So I want to talk about the equilibrium stability, a theoretical issue, a little bit. It doesn't require any mathematics, but it involves a few economics concepts. That's why I want to do it. All I'm trying to teach you is economics, to be honest with you. I'm not trying to teach you mathematics. I'm using mathematics to explain some of the things. You will see at the end of the course, you have learned only economics here, nothing else. Nothing else. Okay, so let's talk about the stability issue a little bit. Not difficult at all. Can I erase this part of the board again? I require that diagram again. Stability issues. All right. Now recall the diagram, the aggregate demand, aggregate supply diagram. Recall that diagram. What you had is the following thing. You had Y here, price here, and suppose this is aggregate demand and this is aggregate supply. This is price, P dot, this is aggregate supply. And you call this the equilibrium point, call that YE naught, in equilibrium level of income. All right? Okay? Now suppose aggregate demand shifts because of autonomous investment increase or consumption increase or something. Aggregate demand shifts from AD naught to AD1, this kind of a parallel kind of a shift. The equilibrium output should, according to the diagram, increase to YE1. All right? But what's the mechanism through which it increases? Well, in a static diagram, we know the intersecting point gives equilibrium. But what's the mechanism through which it reaches? That's the stability issue. As soon as extra demand is placed on companies, consumer goods demand, investment goods demand, demand has both C and I. So it may be consumer goods demand, it may be investment goods demand. As soon as extra demand is placed on firms to produce them, what happens is companies see that, hurry, what to do now? They go to the godown, which is called inventories. They go to their inventories. When they go to their inventories and find out what stock they have, they open the lock, they take the goods out, which are lying in the inventories, and supply to the market immediately. Overnight, they cannot produce the extra good. All right? Therefore, what I'm assuming, or these models are assuming in some sense, is that companies hold inventories precisely because of this. But there can be an unexpected increase in demand when we will have to open the lock of the inventory, the godown, bring it out and meet the demand, because why should we miss the opportunity to make an extra profit? So we should keep inventories. Now, when the extra demand suddenly comes, which was unexpected, inventory changes are unexpected. All right? So there will be some unexpected change or unexpected rise in, say, autonomous investment will create delta INVU, I will tell you what, negative, where delta INVU is unanticipated change in inventories. People didn't expect inventories to change, and unanticipated change, which is unexpected change, is negative. Why negative? Because there is extra demand. So the inventory add was 100 items, units of items. Suddenly when there is demand, it has gone down to 50 units. So the inventory change is negative, it is falling, not increasing, decreasing. So delta INVU, U is unanticipated change in inventory, will be negative. As soon as there is extra demand, I go to the inventory. Then I come to the production manager and tell the production manager, look, there seems to be an investment, extra demand persisting. What to do? Well, then we have to shift our gear, produce more from next day, next month. Right now, meet the extra demand from inventory change, but the inventory stock is going down. So we have to produce extra to first bring the inventory up to the level we want, the desired level. And if the demand persists, we have to increase our production. And we see the demand is persisting. So finally, what happens? The economy starts producing higher level of output because the increase in investment persisted and the increased demand persisted. It didn't go down, one period increase and then it didn't fall. So that it cancelled each other, and a minor inventory change that took place in the company's inventory stocks over 1 or 2 periods. No, I bring back by inventories, again it goes down because they want that extra amount of increase in output to persist in some ways. So the economy will start now producing a higher level of output because there is a higher level of demand that persists. It went up means went up, it never came down. So what I am trying to tell you is that as soon as Y, aggregate demand increases, all right, in order to go there, what happens is there is in the process here, delta INV U becomes negative, which means it is signaling companies to produce more. Your inventory stocks are going down because there is extra demand in the market. When it persists, you have to produce more. In order to produce more, therefore, Y starts increasing slowly towards YE1, equilibrium value. It doesn't reach overnight. It takes time to reach that, and then it reaches that. All right? Similarly, if demand falls, companies cannot sell what they take to the market. So what they do? Arey, we come back, Malik bahut naraj ho gaya. You come back without selling all that. Where will they go? They go into the inventory. Arey, unexpected change in inventory is now positive because the inventory stock what I had in the morning, by the time evening came, it's bigger because I cannot sell it. So companies, when they notice that unexpected change in inventory stock is positive for a few subsequent periods, that means the market is experiencing a slump in demand. So they go to the production floor and adjust and readjust their production level so that the output starts falling to the new output level. So when you reach the new equilibrium level at YE1, again delta INVU will become 0. There is no change because it has reached equilibrium. Until it reaches that, delta INVU will be negative. The inventory stocks will be depleted to meet the extra demand. Once output reaches the new level where it should be, when no more inventories are touched, they remain whatever the desired levels are. All right? So there is no extra demand that requires to be met from inventories. All demand is met now, keeping the inventories intact from the current output. All right? that we have reached an equilibrium point. So whenever we reach a new equilibrium point, inventory changes, unexpected inventory changes become 0. All right? As soon as unanticipated or unexpected inventory changes are either positive or negative, and that persists for a couple of periods, firms immediately know that there is some permanent change that has occurred in the market. Either more demand for goods or less demand. So they slowly therefore starts adjusting their production plans. So that every period they either produce more or produce less to meet the new demand, to conform to the new demand, to match the new demand. Once they match it, inventory के ऊपर कोई pressure नहीं आते हैं. Inventories go back to their desired level. So this is how inventory adjustment signals how output should adjust and the economy adjusts to a new output level, either higher or lower, which when they reach a new equilibrium point where inventory changes become unintended inventory changes. Unanticipated or unintended inventory changes become 0. Am I clear? Yes.
Unexpected inventory change, the negative part, the demand is rising. This is taking two things into account. One thing is, we are assuming that the inventory is large enough to sustain that.
Of course, I am assuming that.
And the second thing is, you said that once it's reached, say, by E1, then there is no pressure on the inventory. That is given. But the inventory will not go back to its original level. There is a
Inventories will go back to the new desired level maybe, but the inventory unexpected changes will be 0.
So the change is 0, but we have already drained the inventory to some extent. Say we had 100 items in the inventory. To sustain the growth, we say took out 50 of them. So now the level is at 50. So if we want the level to be 100, wouldn't the output have to be?
If output has permanently changed, the inventories may not also go back to 100 anymore.
Not replenish.
Yeah, you have to replenish the inventory and the desired inventory level itself may change, for which the company for a few periods would produce more, which will not come to the market, but would produce more to replenish the inventory and put up the inventory. Company may decide, previously we used to have 100 units in the inventory, but if unexpected changes are so large that 100 wasn't sufficient, we would like to rather make it. These are planning goes on in a company. When you join a company, you will see that. Inventory planning goes on. And they may say, okay, let's make it 150 from now onwards. So they will have to take back the inventories to 150 when it reaches equilibrium. Once it reaches 150 and the current output matches the demand, all right, there are no more changes in inventories, we reached equilibrium, according to these macro models. You are absolutely right. Inventories may not be sufficient to meet all the demand, then you don't meet the demand for a few periods. That's why I'm saying from Y0E to Y1E, the new equilibrium value, this on a diagram looks like a smooth line. It may not be at all. It takes a few time periods, it takes a few hiccups, few adjustments, and finally it reaches. Sometimes in macroeconomics, there is also an issue they call overshooting, that they were producing so much extra, they overshot the equilibrium value, and then they will come back. Now, so inventories, I mean, it may not reach equilibrium so easily at all, but once it does, that means it's okay. The new production plan, new inventory stock, everything. But there is another component in inventory change which I didn't discuss. This is unintended. There is a component called intended change, which came up in this discussion, because a company may decide to intendedly, consciously increase the desired level to 150. So that is an intended change in inventory. I will take that up in relation to investment later. But for the time being, notice that whenever there is a shock like that, autonomous investment has gone up, the adjustment process takes time. And the signaling comes to firms that something gadbad chal raha hai, naya chal raha hai market mein, is when they look at the inventory adjustments. If there is unexpected up and down in inventories, for a subsequent quarters or periods, say weeks or days, companies realize now they have to readjust certain things, changes. And that shift to a new equilibrium point is not necessarily overnight. It takes time. So, are you okay with what I've taught? Is it interesting a little bit more? Macro theory models are very interesting, very different, very mathematically not very complicated, but they do talk about many things in the economy. I hope some of you would enjoy. And what I want to do, write one more equation or functional relationship, what I've just said. So, will I be correct to say that just one more thing I need to write? Demand greater than equal to less than y, if demand is more than output, okay, would imply delta INV U, all right, less than equal to greater than 0. If demand is more than output, INV is negative, INVU negative, I told you. If demand is equal to output now, whatever the company produces, then delta INVU reaches 0. If demand is less than output, delta INVU is greater than 0. This relationship ensures that the market reaches equilibrium. Company adjustments ensure that the market reaches equilibrium. This is called a stability condition. The stability is ensured through the inventory adjustments. So whenever companies see unintended inventory changes or something, it signals companies as to what they should do, and therefore they adjust and crawl back to the new equilibrium point. Climb up to that or go down or whatever. All right? This is the basic relationship that I was trying to tell you. In mathematical terms, this is what it is. Are you happy with this, what I said? Okay. Now next day, on Monday, I will complicate this diagram a little bit. I will bring in government, taxes, expenditures. Let's see how you feel about it. Because those were the contributions of Keynes. You will see a very funny thing. These relationships, basic ones don't change, but algebra becomes a little bit more complicated. All right?